Hello and welcome to our lesson on adding and subtracting radicals, a more advanced look. First, let's talk some definitions. A radical is an expression, so no equal sign, that includes a number, right there, a radical or a root sign, and an index. And that number is called a radicand. Now, when you add and subtract radicals, they have to be like terms. You cannot add or subtract terms that are not similar. So if the radicals are not exactly alike, you can't do anything with it. So let's take a look. It's all about what's underneath the radical sign, the radicand. So we have a radicand of 5 and radicand of 5. Are those like terms? Absolutely. It doesn't matter what's going on with the coefficients at all. We're not looking at those. We're only looking at the radicals. So yes, those are like terms. Now how about here? You have a radical 2 and a radical 2. The radicands match. They're both 2. We don't care what's going on with the coefficients, but since these two, the two 2's match, then yes, those are like terms. Now, take a look here. You've got a radical 3 and a radical 4. Even if we go ahead and take radical 4, which is the number 2, then we don't even have a radical here, so these definitely don't match. You have radical 3 and the number 2. There's no matching radicals, so these are not like terms. And then here you've got a radical 2 and a radical 1. They don't match again, and it doesn't matter that you have a negative 9 and a negative 9 for a coefficient. We don't care. It's all about what's going on underneath the radical. They're not the same. They're not like terms, so you can't do anything with them. So let's take a look here. If I have the exact same radicands, I have like terms, and I can do something with them. Here I've got a 108 and a 108. They're exactly the same. Great. But you also have to make sure that both of them are simplified. Is 108 a prime number? No. We can definitely break 108 down further. So let's look at 108 and let's create a factor tree. So I know that 2 goes into there 54 times. 2 is a prime number. I like to put a dot under my primes to keep track of them. Then we've got 54. We can break it into 9 and 6. And 9 is not prime, so 3 is prime, times 3, another prime. 6 would be 3 times 2. Now I've got all these prime numbers. Because there's no index here, it's assumed to be a 2, which means we're looking for pairs to pull out. So I have a pair of 3's, and here's 1, 2, I have a pair of 2's. So actually, I'm going to take out of the radical sign a pair of 2's and a pair of 3's. And this lonely little 3 who's left over stays underneath the radical sign. Now if I simplify that out, this is really going to be 6 radical 3. That's what 108 as a radical looks like. This is the simplified version. I haven't added or subtracted anything yet. I've simply done simplification of radical 108. So that's 6 radical 3. So let's take a look. This turns into 6 radical 3 plus our original 15 from the problem, and then you have to multiply it by that 6 radical 3, which is what 108 converted to, simplified. So first things first, you're going to have to multiply 15 times 6. And once you multiply 15 times 6, you're going to get 90. Did old school multiplication. So you've got 6 radical 3 plus 90 radical 3. Are they the exact same radicals? Yes. We can go ahead and do what it's asking us to do, which is add them. So we're adding 66 and 90, and we're getting 96 radical 3. Is the radicand fully simplified? Yep. This would be our final answer then. That answers the question, what is radical 108 plus 15 radical 108? It's going to be 96 radical 3. All right, let's take a look at the next one. Is 54 the exact same radicand as 54? Is 54 a prime number? Nope. We have to break down 54 first. So let's do our factor tree. And we can do 9 times 6. You could have also done it by 2's. However you want to, you're going to get the exact same prime numbers at the end. So it's going to be 3 and 3. Those are primes. And if we break 6 down, we're going to get another 3 and a 2. And again, there's no index, so it's assumed to be 2. So we're looking for pairs. Let's pull out a pair of 3's, and we have 2 lonely little guys left behind. So that means that this is going to turn into the original 4 times our actual simplified, which is 3 radical 6. And then we're going to subtract a negative 8 times 3 radical 6. All right? Here we have to do PEMDAS parentheses first. You're going to have to do your multiplication of 8 times 3. That's 24. You're going to have to do your multiplication of 4 times 3. That's 12. So actually you have 12 radical 6 minus negative 24 radical 6. Now, if you remember, when you have two negatives running into each other, they're colliding, they turn into a big old positive. So we're actually adding these two together. So you're going to take 12 and add 24, and you're going to get 36 radical 6. And that would be your final answer right there. Okay, so let's look at some more examples. First of all, we have radical 108 and radical 10. They are not the same, so we cannot add them, which is what it's asking us to do. However, before we stop, we have to make sure that we have fully simplified both the radicals. Is 108 fully simplified? No, we just learned that on the last one. Turns out that radical 108 actually was 6 radical 3 when we simplified it. Now, is 10 fully simplified? Well, if we break it down, it's 5 times 2, and this is squared, so we're looking for pairs. There's no pairs, so radical 10 is fully simplified. So our final answer would just be rewriting the actual equation, and it would look like that. Nothing else you can do. Radical 3 and radical 10 are not like terms, so you can't add them together. You like trying to add puppies and tigers. It doesn't work. Two separate piles. All right, let's look at the next one. You have radical 54 and radical 4. Are those the same? No. But are they fully simplified yet? No, they're not. Because take a look. Radical 4, isn't that a perfect square? Wouldn't that be 2? So you'd actually have a negative 8 times 2 inside that parentheses. Now look at the 54. We can definitely break 54 down. It's not prime. We can go 9 times 6. And 9 broken down is 3 and 3. Now we've got a prime. And then if you break down 6, you've got 3 and 2. They're all primes. There's no index, so it's assumed to be 2, so we're looking for pairs. We're pulling out a pair of 3s, and the poor 3 and the poor 2 don't have a pair, so they stay inside. So if we're going to take radical 54, we end up with 3 radical 6. However, you've got that 4 still out there. So it's going to be 4 times the pair of 3s, and then radical 6. And then we're going to subtract it from the other part. So if we do that, 4 times 3 is 12. You're going to have 12 radical 6 minus a negative, and then you're going to have 8 times 2 is 16. Take a look. You have two negatives colliding. They turn positive. So you're going to have 12 radical 6 plus 16. Can I combine those two? No. I've got a radical 6 here, and I don't have a radical on the 16 at all, so they're not like terms. This would be your final answer. That is as far as you can go. You'll be able to stop. Let's take a look at some more examples. 25 and 25, are they the exact same? Yeah, and they're also special too, because isn't 25 perfect square? Wouldn't the answer be 5 if we pull them out of the radical sign? So you really have negative 1/2 times 5. That's this part right here. And then you're going to add 4 times the radical 25, which is 5. So you're taking 1/2 negative, and you're multiplying it by 5. And if you remember, you can create a fraction from a whole number by putting a 1 underneath the whole number. And with fractions, you're going to multiply straight across. So you actually get negative 5 over 2. And for this right here, 4 times 5, you're going to get plus 20. So we're looking to add negative 5 over 2, and we're adding 20 to it. If we do that, we need to make sure that we have the same denominator when you're adding with fractions. So this denominator needs to be a 2. And since I changed it to a 2, I also have to multiply the 2 up here as well. So this actually changes this fraction right here into 40 over 2. Now I can go ahead and add. If I have a negative 5 and a positive 40, I have a positive 35 over 2 as my final answer. Depending on what the directions tell you, you can either leave it as an improper fraction, or if they tell you differently, you're going to have to figure out how to make it into a mixed number. Right now it's improper, and it's good enough for now, and it's the correct answer. Let's go ahead and take a look at the last one. I've got radical 32 and radical 32. Awesome, they match. However, they are not fully simplified. So let's factor tree 32. So you're going to get 8 times 4. 8 is not prime, let's break him. 4 times 2, 2's prime. 4 is still not prime. 2 times 2, great, all primes. And then this guy out here still needs to be broken, 2 and 2. The index isn't written, it's assumed to be 2. We're looking for pairs. I have a pair of 2's, a pair of 2's. Lovely, and the poor little lonely 2 is left over. So your radical 32 is actually going to be 6.4, and then you're going to multiply it by 2 times 2, because we have 2 sets of 2, so that's 4 radical 2. That's for this section right here. Then we're going to subtract the original 8 times another 4 radical 2. Alright? You're going to have to multiply these first. So you end up with 24. And then I'm sorry, that's 6.4 times 4. So that's going to be a different number. So you've got 6.4 times 4, and we're going to end up having a 25.6. So we've got 25.6 radical 2. And then we were subtracting the 8 times 4, which was 32 radical 2. Do we have the same exact radicals? Absolutely. Now we can actually do what it wants us to do. It wants us to take 25.6 and subtract 32. Biggest number is negative, so your answer is going to be negative. So you're going to have a 6.4 radical 2. Is the radical fully simplified? Yeah, it is. That means this is going to be your final answer. All right. Take a look. You have 16 and 1.6. Are those the same? No. Same numbers, but the wrong decimal places. However, they're not fully simplified, so we can't stop just yet. Isn't 16 a perfect square? Wouldn't that be 4? So you're going to have negative 42 times 4, which is going to end up being negative 168. And then here, you've got 1.6, which actually is going to get you to 0.4, because 16 was a whole number, and here you've got a decimal, we're moving it over 1, so if we have the number 4, it turns into 0.4. So you've actually got plus 7 times 0.4. 7 times 4 is 28, and you've got 1 decimal moved over there. Now we've just got a regular addition subtraction problem. So we can go ahead and do that, and when we do that, we're going to end up with a negative 165.2. That's going to be your final answer. We fully simplified them, and when we did, we found out that we could get rid of our radicals altogether. We got a 4 and a 0.4. They turned into whole numbers, and it was just a regular old addition subtraction problem. All right, let's try the last one. Are both of these radicals exactly the same? Yes. Are they fully simplified? Yes, because 53 is a prime number. You can't break them any further, so we can just do what it asks us to do. 31, take away a negative 11. That's 2 negatives colliding, which means they turn into a big old positive number. So they're actually asking us to take 31 and add it to 11. So you're going to get 42, and the radicals are exactly the same, so we're just recopying them. Can't break it down any further, so here's your final answer. Quick review. In order to add or subtract radicals, they absolutely must be like terms. If the radicals are not like terms, you cannot combine them at all. Remember, you have to simplify any radicands that you have, and you can either simplify them at the beginning or you can simplify them at the end. And that's our lesson for radicals, adding and subtracting a more advanced look.